Hello students, in this session we will discuss topic column and strut. In previous sessions we discussed introduction of column and strut and we discussed Euler's formula in detailed way. We also calculated few numericals using Euler's formula. Now in this session we will discuss Rankine's formula in detail and we will solve few numericals. So let's start with this session. Here is the Rankine's formula. Rankine's formula is used to calculate crippling or crushing load for the column section. The formula is applicable to long and short both type of the column. Euler's formula that we discussed in previous session was only applicable for long column, but the Rankine's formula is applicable for both type of the column. So here is the formula. PR is equal to FC into A upon 1 plus alpha LE upon K square. Here in this equation, PR is Rankine's crippling or crushing load. FC is compressive stress of material. Alpha is Rankine's constant. LE is effective length of the column. K is radius of gyration. So we also know that LE upon K, which is effective length of the column, upon radius of gyration is slenderness ratio lambda. So if I replace LE upon K with lambda, then I am getting PR is equal to FC into A upon 1 plus alpha into lambda square. So this is the Rankine formula. Now let's discuss the formula in more detailed way. So here the Rankine is the name of scientist who invented this formula, and he is given one empirical relationship between long and short column. So the relation he has established in short and long column both is 1 upon P is equal to 1 upon PC plus 1 upon PE. Okay, so we can say that 1 upon P is equal to PE plus PC upon PC into PE. Now, if I rearrange the equation, then the equation will be P is equal to PC into PE upon PE plus PC. Now, if I divide numerator and denominator with PE, then I will get equation number 1, which is PE is equal to PC upon 1 plus PC upon PE. Now we know that PC is the crushing load and it is equal to FC into A, and Euler's crippling load PE is equal to pi square EI upon LE square. So if I am putting equation of PC and PE in equation number 1, then I will get P is equal to FC into A upon 1 plus FC into A upon pi square EI upon LE square. Now I is equal to AK square. So I am putting AK square instead of I in this equation, then I will get P is equal to FC into A upon 1 plus FC into A into LE square upon pi square E into AK square. So that I can say that P is equal to FC into A upon 1 plus FC upon pi square E into LE upon K square. Now, if we put FC upon pi square E is equal to alpha, then I will get P is equal to FC into A upon 1 plus alpha into LE upon K square. Now we know that LE upon K is nothing but the slenderness ratio lambda. So I am replacing LE upon K with lambda, then I am getting final equation to calculate crippling or crushing load using Rankine's formula, which is P is equal to FC into A upon 1 plus alpha into lambda square. Now let's solve a numerical using Rankine's formula. So a hollow cast iron section having external diameter 250 mm and thickness 25 mm is used as 4.5 meter long column. So here one hollow cast iron section is there, okay, which is used as a long column. Okay, length of this column is 4.5 meter. So I can say that length of this column is 4500 mm. Now, external diameter of this hollow circular section is 250 mm, and as thickness of this section is 25 mm, internal dimension will be 200 mm. Okay, so value of factor of safety is given, it is 3.5. Maximum compressive stress, which is FC, is also given, it is 500 Newton per mm square. Value of alpha, which is given, 1 upon 1600. Now let's start with the calculation. Here column end condition is given. Okay, so both the end of the column are fixed, and we know that when both the end of the column are fixed, effective length of the column LE is equal to L by 2. Here original length of the column is 4500 divided by 2, then I am getting LE. So LE I am getting is equal to 2250 mm. Okay, now let's calculate area of this hollow circular section. So area of hollow circular section A is equal to pi by 4 d square minus small d square. Here capital D is 250 mm and small d is 200 mm. So I am getting area of this section is equal to 17,671.45 mm square. Now let's calculate I. I is the moment of inertia of circular hollow section. Okay, so I is equal to pi by 64 capital D raised to 4 minus small d raised to 4. Value of D is 250 and value of small d is 200. So I am getting I, moment of inertia of the section, is equal to 113.20 into 10 raised to 6 mm raised to 4. Now let's calculate K. K is the radius of gyration, and equation to calculate radius of gyration is under root I upon A. Value of I, as we calculated, it is 113.20 into 10 raised to 6, and area of this section, as we calculated, it is 17,671.45. So I am getting radius of gyration K is equal to 80 mm. Now let's calculate PR. So PR is equal to FC into A upon 1 plus alpha LE upon K whole square. Value of FC, which is given, 500. Area we calculated 17,671.45 upon 1 plus alpha. Alpha is given 1 by 1600. Value of LE, that is effective length, we calculated 2250, and radius of gyration K, as we calculated, it is 80. So I am getting PR is equal to 59,14,139.89 Newton. I am converting it into kilonewton, so I am getting answer 5,914.13 kilonewton. We also need to calculate P safe. P safe is the safe load, and for calculating P safe we need to divide PR with factor of safety. Factor of safety is given, which is 3.5, and PR, as we calculated, it is 5,914.30. So I am getting safe load is equal to 1689.75 kilonewton. So as given in the data, we have calculated both the load, Rankine load P and safe load. Now let's calculate one more numerical. So here a solid iron circular column of 4 meter height is to be erected such that its one end remains fixed and other end remains hinged. So here column end condition is given. One end of the column is fixed and other end of the column is hinged. Also, length of the column is given, which is 4 meters. So I am converting it into mm. I am getting length is equal to 4000 mm. We need to find size of the section. If column has carry a safe axial load of 300 kilonewton, here P safe is given, which is 300 kilonewton. Again, factor of safety is equal to 5 given, and maximum compressive stress is equal to 500 Newton per mm square is also given. Also, value of alpha is given, which is 1 upon 1500. So these are the given data. Now let's start solving our numerical. So first of all, we will calculate LE, which is effective length of the column. Here column end condition is that one end of the column is fixed and other end is hinged. So LE is equal to L upon under root 2. Value of L, which is original length, it is 4000 upon under root 2. So I am getting effective length of this column is equal to 2828.43 mm. Okay. Now let's calculate PR. Okay, PR is the Rankine load. Okay, here P safe is given 300 kilonewton, and this is the equation to calculate P safe. So P safe is equal to PR upon factor of safety. So we can say that PR is equal to P safe into factor of safety. Okay, P safe is 300 and factor of safety given 5. So I am getting PR is equal to 1500 kilonewton. Okay, now let's calculate area of the section. Here we need to calculate size of the section, so D will be unknown. Okay, so area is equal to pi by 4D square. So we can say that area is equal to 0.785 D square. Now let's calculate I of the section. I is the moment of inertia of the section, which is pi by 64 into D raised to 4. Again, D is unknown, so moment of inertia is equal to 0.0491 D raised to 4. Okay. Now, let's calculate K. K is the radius of gyration, and equation to calculate K is under root I upon A. Here, I, as we calculated, it is 0.0491 D raised to 4 upon area, as we calculated, it is 0.785 into D square. So I am getting K is equal to 0.25 D. Now PR is what? PR is equal to FC into A upon 1 plus alpha LE upon K square. So value of PR, as we calculated, 1500 into 10 raised to 3. Okay, we are getting value of PR is equal to 1500 kilonewton, and I am converting it into newtons, so it is 1500 into 10 raised to 3. Now FC, which is given 500, area as we calculated, it is 0.785 D square upon 1 plus alpha. Alpha is given 1 upon 1500. Now LE, as we calculated, it is 2828.43. And K we calculated, it is 0.25 D. So I am getting 1500 into 10 raised to 3 is equal to 392.5 D square upon 1 plus 85333.5 upon D square. So ultimately I will get D is equal to 141.69 mm. Okay. So this is end of the session. Thank you.